We have the first derivative and the second derivative tests that help find local extrema, local min and max. And what we mean by local is that they are the min and max in kind of their neighborhood, but they may not be the min and max everywhere. So an analogy of that would be, I know the highest point in, let's say, Oklahoma may not be the highest point in the United States, but locally it is still the highest point. All right, so here we have an example of a graph, and you can find the local min here and the local max there through finding the critical points, which means setting your derivative equal to 0, and then doing either the first or second derivative test. All right. However, in this case, there is no absolute max. There's no point that's actually the highest or the lowest, because I go to positive infinity in this direction and I go to negative infinity in this direction. But if I close this function onto a closed interval, so I truncate my domain, let's just say I just define my domain to be from there to here, for example. And so now those tails are gone. This is the only place this exists. I can find an absolute min and max, and in fact, there will be one every single time if you have a continuous function. And so how do you determine now the min and max? The strategy is basically the same. I need to find my critical points. Okay, so I found these two critical points. Find that from the derivative, set it equal to 0. And then I also need to determine what the value of my function is at the endpoints. So here, all I have to do then, instead of doing a first or second derivative test on this, all I have to do is find these points and those points and just plug them in and see which one's the highest, which one's the lowest. And so here I can see this is my absolute max. That is the highest point on the graph. And this is my absolute min. So it can come from either a critical point or one of the endpoints. And those are the only points you have to test. And I'll show you an example how this works. It's pretty simple, but I'll show you an example how it works. So now I want to find the absolute extrema of f of x, which equals x squared minus 1 quantity cubed, on the closed interval -1 to 2. So we just saw that if there is a closed interval, I know for sure that I will have absolute min and max, since f of x is continuous. Alright, so the first thing you want to do is to find your critical points. And basically what we're doing is building a candidate list of what our absolute extrema could be, our absolute min and max. What could they be? They're either from the critical points or they're from the endpoints of our interval. Alright, so I take the derivative, and here, we have to remember how to use chain rule to do this. So that's going to be 3 times x squared minus 1 quantity squared times the derivative of what's inside, which is 2x. You set that thing equal to 0. This is actually pretty straightforward because it's factored for us already. So you set this equal to 0, and you can end up with, from this part, you end up with x equals plus or minus 1, and from 2x equals 0, you end up with 0. So those are your critical points, and notice that these values all are within this range. You may have examples where you find a critical point outside of the domain that you're considering, so you don't even have to worry about that. You can just throw it out. Here we do need to include all these, but that's okay. So my candidate list includes these negative plus or minus 1 and 0 and negative 1 and 2. So negative 1 is listed in both cases. And all I have to do now is just test. Since I know that these are the only possibilities for absolute min and max, I just need to figure out which one of these is the highest and which one's the lowest. So I'm going to plug in f of -1, f of 0, f of +1, and f of 2, and see what they are. Okay, so you can work the arithmetic out here. So if I plug in -1, I get -1 squared, which is +1 minus 1. That's 0. Quantity cubed is still 0. If I plug in 0, I get -1 cubed, so that's -1. If I plug in 1, just like -1, you're going to end up with 0 again. And if I plug in 2, I end up with 4 minus 1, which is 3, and 3 cubed is 27. Okay, so just from this, you can easily see I have -1 as my lowest point and 27 is my highest. So in conclusion, you say, we can say we see f of x has an absolute maximum at the point 2, 27. and an absolute minimum at where? 0, -1. And it should be pointed out that this is only true because we're on a closed interval. If we didn't close that interval off, this may not be true anymore. In fact, it wouldn't be. So we need to say on the domain of -1 to 2. Okay? I hope this makes sense. Please let me know if you have questions. I'll be glad to help. And thank you for watching.